So as we mentioned in the fourth and final of the common Maclaurens, 1 over 1 minus x has an interval of convergence. It's only valid if x is between -1 and 1. But for e to the x, sine of x, and cosine x, those series, those Maclaurin series, they converge onto the function for all values of x. All real numbers, doesn't matter what x is, doesn't matter what happens, the series will match up entirely with the actual function. You can actually see this if you graph both the series and the function. If you put out enough terms, you'll see that the series is going to map onto the function and converge. It's going to take a lot of terms, but it can actually be done. How can we prove it otherwise? Well, remember how we find our interval of convergence. We do a ratio test. Let's take the e to the x series, which I've written right here. All right, n goes from 0 to infinity, x to the nth over n factorial. We already have the first couple of terms down from a previous video. I'm looking at the general term right now. What if we were to perform a ratio test on this? All right. Well, that means that we would have the limit as n approaches infinity, and we have the absolute value of the n plus 1th term divided by the nth term, which again we're multiplying by the reciprocal, so we're going to have n factorial over x to the nth. And the ratio test converges if this limit is less than 1. Well, let's take a look at what's going on with this limit. Let's simplify it like we've done in previous videos. X to the n plus 1, that's really x to the nth times x, and our x to the n's wipe out. N plus 1 factorial, that's really n plus 1 times n factorial, and the n factorials wipe out. So what are we left with? The limit as n approaches infinity. Up in the numerator, all we've got is an x. I'm going to leave that in the absolute value. In the denominator, I've got this n plus 1. Right? And I need that limit to be less than 1. Well, take a look at what's happening here with this limit. Where's the largest degree? It's in the denominator only, which means that this expression right here, as n approaches infinity, that limit is heading towards the value of 0. So we have 0 times the absolute value of x. Right? 0 times anything is 0, and 0 is always less than 1. So our series will always converge. Doesn't matter what x is. So e to the x, that series, that 1 plus x squared over 2 factorial plus x cubed over 3 factorial, so on and so forth, that converges no matter what value of x you're interested in. The same thing's going to happen with sine and cosine. But again, that's not the situation with the fourth of the common Maclaurens. All right, 1 over 1 minus x does have the interval of convergence. Now that you've got them, we need to memorize them, and we have to use them. That's what these next videos are doing.